We solved 4 sums in the previous 2 parts and got the following answers. 0.3 with a bar over 3 as 3 by 9, 0.75 with a bar over 5 as 68 by 90, and 0.352 with a bar over 352 as 352 by 999. And the last one was 0.2394 with a bar over 94 as 2371 by 9900. What we did was convert the decimals to the rational number form p by q. But the procedure we used was very long and arduous, which made it time-consuming and boring. Let's look at a shortcut, a quicker way to solve it. First, let's classify the decimal numbers into simple or mixed recurring decimal numbers. The first decimal is simple since all the digits after the decimal point are repeated. Even this number is simple since 352 is repeated after the decimal point. They are also called pure recurring decimals. In the second example, the bar lies above the number 5 and the digit 7 is not repeated. So it's a mixed recurring decimal. In this example too, only 94 is repeated and not 23. Hence, it's a mixed decimal too. Now let's focus on the simple decimals. Do not look at the answer for now. The denominator of the fraction will have as many 9s as the number of recurring digits. Here, we have just one digit that is recurring, it's 3. So the denominator will be 9. And finding the numerator is even more simple. We write the number without a decimal or the bar. It will be 3. That's it. There's your answer. No equations, no subtraction, no variables, nothing. Let's understand it with another simple recurring decimal. The denominator will contain as many 9s as the number of recurring digits. Here, we have 3 recurring digits, 352. So we will have 999 in the denominator. And the numerator without the decimal or the bar, 352. That's it. There's your answer. 352 by 999. Remember, for simple decimal numbers, the denominator will have as many 9s as the number of recurring digits, and the numerator is written without the decimal point and the bar. Now let's get to mixed recurring decimals. This is a little tricky, but very interesting. Again, the denominator contains as many 9s as the number of recurring digits. Here we have only one digit that's recurring, it's 5. So we write a 9 in the denominator. But wait, we are not done with the denominator. We write as many zeros as the number of non-recurring digits. We have one non-recurring digit here. It's 7. So we write 1 0 here. That's our denominator. What about the numerator? Again, we write the number without the decimal or the bar, which is 75. And we subtract the non-recurring number from it. The non-recurring number is 7. So we subtract a 7. That gives us an answer of 68 by 90. Remember, the only difference here is the 0 for the non-recurring digits and the subtraction of the non-recurring number. Let's try it out with this number now. It has 2 digits which are recurring. So we write a 99 in the denominator, and there are 2 digits which are non-recurring. So we write a 00 next to 99. In the numerator, we write the number without a decimal or the bar. And then we subtract the non-recurring number, which is 23. That gives us the answer as 2371 by 9900. So these simple steps give you the answer in like 10 seconds. Don't worry about the rules. They are mentioned in the summary section. But here's an interesting question. Until now, we have only looked at numbers like 0 point something. What if we have a number like 2.3 with a bar over 3? It's simple. We just write it as 2 plus 0.3 bar. We know how to write 0.3 bar in the p by q form. We take a scratch paper and use our technique to write 0.3 bar in the p by q form. Since it's a simple recurring decimal and we have just one digit which is recurring, we write the denominator as 9. As many 9s as the number of recurring digits. And the numerator is the number without a decimal or the bar, hence 3. This can be reduced to 1 by 3. So this can be written as 2 plus 1 by 3, which is 2 1 by 3 in mixed fraction form, or 7 by 3 in the p by q form.